Hi guys. So yesterday we learned about using the STP conditions for 1 mole of gas, and the volume is 22.4 liters. So now we're going to talk about, well, what do you do when it's not at STP? So when gases are not at STP, we can still use the STP conditions to solve the problems, and we're just going to use the combined gas law then to answer questions. So remember, what is the combined gas law, which was not on your quiz, incidentally. So P1 V1 over T1 equals P2 V2 over T2. I'm also very excited because I figured out today that if I wear a mitt, a little glove while I'm writing, my writing's a lot better and the stylus works better. Small things. It only took me 7 weeks, hey? Pretty good. Okay, so we're going to work through a question here. So what volume of hydrogen would be required to produce 0.400 moles of HCl at 57 degrees Celsius and 450 millimeters of mercury? Now, if we go back to what we did yesterday and we pretend that that's at STP, this is a fairly simple problem. We're going to use one bracket. We're just going to use our dimensional analysis, use our conversion factor of 22.4 liters for 1 mole, and just convert it into volume that way. But because this is not at STP, we've got the 57 degrees and the 450 millimeters of mercury. That tells me that I can't use that. I have to do something else to it. So how we do these problems, you're going to first convert to volume at STP. So you are going to pretend that it's at STP or solve for it at conditions at standard temperature and pressure, STP. Once you've got that, that will be your volume. That you're going to set that as V1. So then your T1 and your P1 are going to be all at STP. So remember though, this one you have to solve for. The second step, then we're going to use our combined gas law where our V2, T2, and P2 are the variables that are going to come from the question. So the 57 degrees Celsius, we'll first convert that into Kelvin. That will be our temperature. The 450 millimeters of mercury will be our P2, and we'll solve for V2. Okay, so that's the strategy. Those are the steps. So I'm going to go ahead here and just solve for the volume then at STP. So if I want to find the volume of H2, so it's going to be liters of H2 is going to be equal to, I know, so use your dA like we always do, 0.400 moles of, oh man, I forgot to balance the equation first, sorry guys. It's going to be H2 plus Cl2 goes to HCl. So the ratio between them then is going to be 2 here, and then I'm going to need, yeah, that's it. Okay, so the 1:2 ratio. So I'm looking for the volume of H2. That's my question mark there. So liters of H2 is going to be equal to 0.400 moles of HCl. My first step then is going to be to use the mole ratio to convert that into moles of H2 because we always have to work through the mole. We can't do anything until we solve for moles. And looking at the ratio between them, I know it's a 2-to-1 ratio here. So if I stop the problem right now, I would be in moles of H2. You don't want that though. You want to get to liters of H2. So you're going to need another bracket, another conversion factor. And we know that in 1 mole of H2 at STP, we have 22.4 liters. So now you're going to get your calculators out and you're going to solve for this. So we're going to have 0.4 multiplied by 22.4 divided by 2. And you get 4.48 liters. So 4.48 liters. So don't worry about your sig figs yet. You can keep as many digits as you want until the end, right? So this 4.48 liters, this is V1, okay? And this will be the volume of H2 at STP. Okay, so 4.48 liters. Okay, we're going to do the second part now of this question where we use the combined gas law. Okay, so I'm going to set my variables up here. P1, V1, T1. Okay, so remember, these conditions are at STP. So the pressure at STP, now I can say 1 atmosphere of pressure, but if I look back, the pressure here is given in millimeters of mercury. So I'm going to go ahead and use that unit just to keep it easy. So 760 millimeters of mercury. The initial volume here, sometimes people make mistakes and they try to put 22.4 in here. That's not the volume. The volume that you're going to use is what you calculated here, the 4.48 liters. So this is going to be 4.48 liters. Sorry, my 4 is a little funny. 4.48 liters. My temperature, that's the temperature at STP. Remember to put it into Kelvin. So it's going to be 273.15 Kelvin. Now my secondary conditions, so this is P2, V2, T2. These are the ones that are given to you in the question. So let's just go back. And I know that I've got 57 degrees Celsius and 450 millimeters of mercury. So 57 degrees Celsius. So right away, I'm going to convert that into Kelvin. So 57 plus 273.15 is going to give me 330.15 Kelvin. P2, was it 450? Oh, I can't remember. Yes. So P2 is going to be 450 millimeters of mercury, and V2 is what you're looking for. You're looking for volume. So now you can use your combined gas law. So P1 V1 over T1 is equal to P2 V2 over T2. Now, rearranging the formula, again, this is what people find difficult a lot of the times. So use the little trick I gave you. You're solving for V2. Draw your diagonal. Everything on the diagonal goes to the bottom. So T1, P2 goes to the bottom. P1, V1, T2 goes to the top here. Let's make sure it's all correct. Okay, I'm going to move up here. So V2 is going to be equal to, and now we're just going to sub in our values. So I've got 760 V1 4.48 multiplied by T2, so 330.15, all divided by T1, which is 273.15, multiplied by P2, which is 450, and then we just solve. So 760 multiplied by 4.48 multiplied by 330.15 divided by 273.15 divided by 450. And you get an answer of 9.1451. But let's go back and check our sig figs. We've got 3 here, 2 here, 2 here. So I can only have 2 sig figs in my answer. So it's going to be 9.1. So you can round it or put a, well, I guess if you're typing it in, especially how we're having to do things now, you'll put round it. The unit V2, it's going to be liters. Okay, so that's how you do those questions. They're all pretty much exactly the same. So you're always just going to solve for the volume at STP and then use those initial conditions as STP, and you're comparing it to the secondary conditions, which are the ones that are given to you in the problem. Okay, so try those. Your assignment is going to be exercise 9. This is gases not at STP. And again, you've got the answer key already. And then you can start exercise 10 whenever you want. The unit's now done. So exercise 10 is the review. I think most of the questions have answers for the review, but we can have a Zoom meeting on Thursday or Friday. Honestly, probably be Friday because I don't think many of you will look at it before then. We'll have a quick meeting on Friday for any questions that you may have, and then the test, so the unit test, will be on Monday, which is May 11th, and I think we'll do that at 2 p.m. again, and more details on that to follow. Okay, thanks guys.